All right, so here we go. Very first question. It says define all excluded values. And what they really mean for this one is that you set the denominator equal to 0. So first question is v squared minus 11v plus 18 over v squared plus 5v minus 24. Okay, so if we take the denominator, set it equal to 0, we're looking at v squared plus 5v minus 24 equal to 0. And for this one, you're looking for the factors of negative 24, where the sum would equal positive 5. And if you check it for that one, that should be a positive 8 and a negative 3. And when you set those equal to 0, you're basically going to change those signs. So v would equal positive 3, and then this v would equal negative 8. And I think just like almost all the other questions in the homework, when you're solving those, they're going to have you put the two answers separated by a comma. Okay, number 2 is going to ask you to multiply, and that's the only direction it's here. Really, though, when you're going through this one, what they should tell you then is that you want to factor and cancel. And most of the time, that's half of the battle. Is they give you direction, but then what does it really mean? So even though it says multiply, you're really not going to do any multiplying. Okay, so when you start factoring everything, top fraction, you've got a 3 you could take out. That's the greatest common factor, so make that 3 times x plus 3. For the bottom part of the fraction, the factors of 2 that would equal 3, well, it's got to be 2 and 1. And for that one, they're both going to be negative. For x squared minus x minus 2, against the factors of 2, so that's got to be 2 and 1. And then it's just a matter of, since the middle term is negative, the 2 needs to be negative and the 1's positive, and then we've got the x plus 3 on the bottom. And once you've got everything factored, now you can start canceling. You can get rid of the x plus 3's. You can also get rid of the x minus 2's. And those are one little number different because this is x plus 1. That one's x minus 1, so those don't cancel. So your final answer would be 3 times x plus 1 over x minus 1. Okay, and then number 3, sticking with the fractions, with the expressions, but this one changes gears. This one just asks you to subtract. So you've got 7 over x minus 5 over x plus 2. Key thing on this one is, when you're doing the addition or subtraction, is you have to find the least common denominator first. And for this one, you have two different denominators. This one's x plus 2. So in that case, that would be your least common denominator would just be x times x plus 2. Because you've got two different denominators. Okay, so we're going to rewrite both of the fractions with x times x plus 2. And then what we've got to figure out is, we had the 7 here, had the minus, and the 5 here, is we've got to figure out, okay, from this fraction, from here to here, we went from x to x times x plus 2, so we multiplied the bottom by x plus 2, which means we've also got to multiply the top by x plus 2. For this fraction, we had the x plus 2 and multiplied by x on the bottom, so we've also got to multiply by x on the top. Alright, now, and before you start canceling, remember for this one, you've got to put it all together and make it one big ugly fraction before you can do any cancellations. That you've got x times x plus 2. Well, you've got to bring over the first part, which was 7 times x plus 2, and then minus the 5x. So you're going to work on just the top part of it. And that's almost one of those where we said you could almost go back and just write in the LCD and not even write down what that least common denominator is. Just take that out for a little bit and just put in that that's the least common denominator. If you'll go ahead and write it in, you can, but just sometimes, just to fight the temptation, if you just write down what the LCD is, then you're not worried about doing anything with it. Okay, so first thing is you've got distributive property. So 7 times x, 7 times 2, minus the 5x, and that's still over the least common denominator. So you got 7x minus 5x, which is 2x, plus 14. Now, now you've done pretty much all you can do on the top. I guess you could take out the 2, because you've got 2x plus 14. So you could factor 2 out of those. And then put your least common denominator back in. And at the very end, that's when you want to see if you can cancel. There's nothing that's the same, so for that part of it, that would be your final answer. And you really could put either one of these two answers. Either one of these two should be okay. Because whether you factor the 2 out or you leave the 2 in there, really either way you go, it doesn't really matter. Okay, question 4. I ask you to solve, and then it says after you solve it, graph on a number line. So that means we've got to be looking at some less thans or greater thans. So go with 2x plus 4 less than or equal to 16. And 3x minus 3 is greater than negative 15. Okay, and again, the key word is whether it's and or. If it's and, that means we're looking for the overlap. That's what they have in common when we finish these two graphs. Okay, so to solve it, just work it out right underneath it here. We've got 2x less than equal to 12. Divide both sides by 2. That's x less than equal to 6. For the right-hand equation, we're going to add 3 to both sides. So 3x is greater than negative 12. Divide both sides by 3, so we've got x is greater than 4. Okay, so if they ask you to solve it, that would be the solving part of it. Okay, now to graph it. That's where you're going to need the two values that you have, in this case the -4 and the 6. Okay, and we're looking for the overlap on this one. So if we do the x greater than or equal to 4, do that in green, that one should be an open circle. Head off in that direction, because again, the arrow that you have here should match the arrow that you have here. And for the x less than or equal to 6, we'll do that one in red. That's a solid circle here. Head in that direction. Okay, and that's almost really like showing your work for this part. You put the two graphs on here, and wherever you have the red and green, that's going to be the answer that you're looking for. So your actual answer would be -4 and 6. With an open circle at -4 and a solid circle at 6. Okay, and again, just remember that when you're doing that one, the key word is going to be whether it's and or. If it's and, it's whatever they have in common. If it's or, then it's anything and all that covers the graph. So if that had been an or statement in the original part up here, everything gets covered, that would have been all solutions, because you would have gone from negative infinity over to positive infinity. So again, that graph here was just kind of showing the work here. That we were just putting the two graphs on here so that we could see that we need the overlap. Okay, number 5. Really should have almost gone with number 3, because they basically were the same questions. So for number 5, same deal as we had on number 3. This time we're adding instead of subtracting, but it's still the same thing. You have to find the least common denominator. Now, the biggest difference on this one is your least common denominator doesn't quite jump out at you because you've got two separate things. And before you find the least common denominator of this one, you want to factor out your two denominators. Okay, so for the one on the left, this is where we're going to do bottoms up. So we're going to have to do 4 times 27, which is 108, and that's what we're looking for the factors of. And we're looking for the factors of 108 that's going to have a sum of positive 21. Okay, it's not going to be 1 and 108. Not going to be 2 and 54. Three and 36, we're getting a little bit closer. 4 and 27, still getting closer. 5 doesn't go if we check 6. 6 will go 18 times, so it makes 24. We'll check 8. Let's see, does 8 go? 13 times 8. It's 104, so 8 doesn't go. So let's check 9. If we do 9 times 11 would be 99. 9 times 12 would be 18, 108. Okay. So we've got 9 plus 12 does add up to be 21. And then 9 times 12 is 108, so that's the factors that we're looking for. Now, the biggest difference on that one. We've got the x plus 9 and x plus 12, but the original problem back up here, we had that it was 4x squared. So that's where we've got to take both of these numbers and go back and divide it by 4 if we do the bottoms up part. So that would make this one. 9 over 4 doesn't simplify, so we'll pull the 4 up in front of the x to make it 4x plus 9. 12 divided by 4 is 3. So that makes that x plus 3. Okay, a lot more work on that one than we had on the first couple of problems there. Okay, second problem, we had 4x squared plus 17x plus 18. So if we do 4 times 18, that is 72. And we're looking for the factors of 72, where the sum is going to equal positive 17. Okay, again, 1 and 72 not going to work, 2 and 36. If we go with 3, it's 3 and 24. Of course, we had the 4 times 18, but that didn't work because that was close, 22. 5 doesn't go. 6 times 12 doesn't go. 7, if we do 8, that's 8 times 9. So 8 plus 9 is 17. So that's the pair that works for that one. Okay, but same thing. This one we have to divide it by 4 because we multiply by 4 in the beginning. 8 divided by 4 makes that 2. And pulling the 4 up in front of that one's a 4x plus 9. Okay, a lot of work so far. And least common denominator for this one is basically we need one of everything that shows up. They both have a 4x plus 9. This one has an x plus 3. That one has an x plus 2. So that becomes our least common denominator. Okay, so here's what we're going to do. We're going to take the original problem that we had and rewrite it with the denominators factored out. So this was 9 over 4x plus 9 and x plus 3. The second one was 3 over x plus 2 and 4x plus 9. Because you want it in factored form. Then go back and put in your least common denominator. And again, if you want to just put this is the LCD, that might help a little bit. And this one we had the 9, and this one we had the 3. Okay, so we had 4x plus 9 and x plus 3. To get to the least common denominator, we had to multiply by x plus 2. On the bottom, we're going to do the same thing on the top. for this fraction, we had x plus 2 and 4x plus 9. You had to multiply by x plus 3 on the bottom. So we'll do the same thing on the top. And again, just so that you don't get the temptation to go back and cancel too soon, just leave LCD in the bottom and you're really going to work out the tops. So it's 9 times x plus 2 plus 3 times x plus 3, and that's all over your least common denominator. And again, if you write out that it's just the least common denominator, you're not tempted to cancel anything, so start multiplying out, because that's the only thing left to do. 9 times x for 9x, 9 times 2 for 18, 3 times x, and then 3 times 3. Okay, and then put it all together and see what you have. 9x plus 3x is 12x. 18 plus 9 is 27. So you've gotten everything out as much as you possibly can, except for the top, that you do have 12x plus 27. You can divide both of those by 3. So if you factor out a 3, leaves you with 3 times 4x plus 9. And once you've got the top part worked out as far as you can possibly do, then bring back in your least common denominator. Which was 4x plus 9, x plus 3, and x plus 2. And then at the very end, now you can go back and see what you can cancel. You do have the 4x plus 9 here and here. So final answer would be 3 over x plus 3 and x plus 2. Okay, the good news is there's only one of those. That's a long problem. It takes a long part to get through that. That's probably, I would pretty safe to say that is the longest problem on the test by any stretch of the imagination. And the biggest part of it was doing all the factoring on the two denominators, because it wasn't just x squared, because that denominator started off with 4x squared here and 4x squared here. You had to do the long bottoms up division to get through each one of those problems. Okay, number 6. Definitely a lot shorter. And it was still the same direction that this one said to, I think, add or subtract on this part. And this one, you've got a complex denominator, or complex fraction. And with this one, because you've got a fraction inside a fraction, really there's one thing we can do for this one. Anytime you add or subtract, you still want to find out what your least common denominator is. The good news with this one is there's only one denominator, that you've got a w here and then you've got a w here. So your least common denominator is w. And once you find the least common denominator, you're going to multiply all the terms. By the least common denominator. So where we've got 5 plus 1 over w, multiply this times w and this times w. And same thing on the bottom, multiply both of those terms by w. And because you have the fraction on these two back here, if you want to put that w over 1, you can do that just to kind of keep it in the right place. And once you do that, it should make this thing look a lot better. You've got 5 times W, which is just 5W. For this part, the two W's will cancel each other out and leave you with 1 over 1, which is just 1. On the bottom, same kind of thing. You've got 3 times W. And for that part, same thing. The W's cancel each other out and leaves you with a minus 1. And remember, this is the part where you don't want to go back and cancel the W's and the 1's. That you have to kind of think that these two expressions have parentheses around them. Because anytime you have addition and subtraction with the variables, they're always going to be kind of considered together. And since those are two totally different things, well then that would just be your answer. 5W plus 1 over 3W minus 1. All right, number 7. We'll ask you to solve. And again, still a fraction involved with this one. So whether you're adding or subtracting, like we've done on 3 of the last 4, even with the solving, you still want to do the same thing for these. You still want to find the least common denominator. Okay, and you only have one denominator, so in this case that would be x plus 7. And here's where this part is similar to the last problem. That with the complex fractions, or if you're solving for these, once you find the least common denominator, then you multiply all the terms by the LCD. So we take the 5x and the x plus 7 and multiply it by x plus 7. And again, because it's a fraction, if you want to put over 1, you can put it over 1. Equals 7x over x plus 7 times x plus 7 over 1. And then plus 5 times x plus 7. And once you do that, all the fractions should be gone because the x plus 7 will knock itself out here and here. Leave you with 5x. Same thing on the next one. X plus 7s will knock each other out. And then just a little bit of distributive property on the end. It's 5x. Plus 35. And now that all the fractions are gone, it's just a regular solving equation. So combining the 7x and 5x together to get 12x. We need to get the x's on one side, numbers on the other, so the last thing to do here would be to subtract 12x from both sides. So we'd have a negative 7x equal to 35. Divide both sides by negative 7. And we get x equals negative 5. Okay, and this is one they would tell you to go back and check your answers. The main thing back here is when you check this is that your excluded values is whatever the denominator is equal to 0. So for that, that's negative 7. So that's just one little extra. Now, it shouldn't, most of the time with these, it probably won't work out, but just on the safe side of it, they tell you to go back and check the answers, that if your answer was -7, which this one wasn't, you'd have to throw that answer out. So if the answer we'd gotten had been -7, we'd have had to throw that answer out and rejected it and said, all right, this one would have had no solution. All right, for 8. Back to systems here. You got 7x minus 3y equals 1, -4x plus 5y equals 6, and they're going to ask you to find the solutions, or find solutions. And this is where they'll give you a box that's over here. And they'll give you the ordered pairs. Okay, and this is where you just basically take one at a time, plug in the equations, and see if it comes out to be a yes or no answer. And the big thing on this one is that when you plug in the numbers, it has to fit in both. If they both fit, if both the answers are yes to both of the equations, then that's a yes answer. If either one's a no, then it automatically becomes a no answer. Okay, so we're going to check -2, -5 and see if it works. So if we plug it in the first number, it's 7 times -2 minus 3 times -5. And the question is, does that equal 1? It's -14 plus 15 equal 1. So that part's good. So if that works in the first equation, then we're good. Then we also have to take -2 and -5 and check it in the second equation. So now it's -4 times -2 plus 5 times -5. Does that equal 1? That's 8 plus -25. Does that equal 1? Not even close. So for that one, that's a no. Okay, and then we'll do the same thing with the next few points. Plug in the point 1, 2. And we'll check it in both of them, see if it works. So we have 7 times 1 minus 3 times 2. Does that equal 1? 7 minus 6 equals 1. Yep, that one works. Okay, and then we'll plug in the next point 1, 2 into the next equation there. So that is -4 times 1 plus 5 times 2. Does that equal 6? So that's -4 plus 10. Does that equal 6? I believe it does. So 2 yeses. So that means that that ordered pair would be a yes. So we check that one off there. Okay, and just to save us some time for the rest of them, if you go back and check 0, -8, that would have been a no. If you check -9, -6, that one was also a no. Because the rest of the way out, it's just plug in the numbers and work it out. It's the same thing, just over and over and over there. Okay, 9 and 10, you get a system for 9 and 10, and for these two, they don't give you the checklist. They basically just say, all right, take the system that we have here and let's solve it. So for number 9, let's go with y equals 2x plus 11, and then the second equation is negative 5x plus 4y equals 32. Okay, and with these you have two choices that you can do. You can either do substitution or you can do elimination. Since this one has y equals, this is the one that's probably going to be easier to do substitution. Because we can take this y that's here and we're going to replace y with (2x plus 11). So in this equation we're going to take out y and we're going to replace it with 2x plus 11. Because this one we had y equals, so down here we're going to take the y and replace it with 2x plus 11. Now it's all in one variable, and just work it out and solve from there. We've got negative 5x, 4 times 2 is 8x, 4 times 11 is 44. So that is 3x plus 44 equals 32. Subtract the 44. 3x equals negative 12, so x would equal negative 4. And once you have the x equals negative 4, plug that back into either original. So plug that back into any original equation that we have and use that to solve it. Now, and for these, usually the one that you, with substitution, whichever one you use to replace this with, that's the one we're going to use. So let's plug it back into y equals 2x plus 11. So we're going to take out the x that's here and plug in negative 4. So y would equal 2 times negative 4 plus 11. That's negative 8 plus 11, so y would equal 3. And they should give you two separate boxes to go back and plug them back in your x and y values there. Okay, for 10, 3x minus 8y equals 3. And we're going to do negative 3x plus 13y equals negative 18. And for this one, because it's already lined up and we don't have just an x equals or y equals, this is the one you want to do addition or elimination, whichever way they want to call it here. So you're looking for the same variable with the same numbers, just different by the plus or minus sign, and we have that right here with the x's. And since that's the case, then just go back and add those together. 3 minus 3 makes that 0x. Negative 8 plus 13, or 13 minus 8, makes that 5y. And 3 minus 18 is negative 15. And if you do 0 times x, of course that's 0, so that part just goes away, so you're left with 5y equals negative 15. By those two, and you get y equals negative 3. And same as the problem before, plug that into any original. Find the x value is going to be. Now the difference on this one is the first one, because of substitution, there was a definite easier one to pick to plug it into. For this one, there's not an easier one. Really, it's going to be the same either way. So it's just a matter of which one you want to use to plug it into. So just pick one, and it doesn't really matter. If you want your x to be positive, let's go with the first one up here. So we're going to take out this negative 3 and plug it in right here. So that's 3x plus 24 equals 3. Subtract the 24 from both sides. And divide, and we get negative 7. Okay, so one substitution. This problem was elimination. And again, a little bit different. First steps are always a little different to get the first value, but the second one, it's still always the same, that once you find the first value, take that value, plug it back in, and once you plug it back in, then you can find out what the other value would be from the other equation, for the other variable. Okay, for 11, they give you two functions, and they're going to ask you to find two different values. You're going to find f of 4, and then you're going to find g of 7. And since you have two different functions, you're looking at two different answers. So you'd almost go back and just draw a line right down through the middle of it. That you're going to use f of 4 in this equation, then you're going to use the 7 in this equation and work it out from there. And when you have f of 4, everywhere you have an x, you replace it with 4. Same thing on this side. Everywhere you have an x, replace it with 4. So it's negative 2 times 4 squared minus 3. And you never do anything with this left-hand side, this f of 4. That's just a marker that's here, so you're basically just going to work this side out. 4 squared is 16. So then negative 2 times 16 would be a negative 32. Minus 3 would make that a negative 35. And g of 7 is going to be the same thing. Everywhere you have an x, you've got to take the x out and replace it with 7. So over here, you're going to take the x out and replace it with 7. So a little bit easier on this one. Negative 3 times 7 is negative 21. Minus 3 makes that a negative 24. right, a couple more, and then they'll get short on the questions here in a hurry. Just takes a while to get through the first half of the test. It's kind of long. The second half of the test goes really, really quick. All right, number 12. This is one that asks you to solve. And it's back to the compound inequalities. Now, this one doesn't ask you to graph it. This one they ask just strictly for a solving on this part. And the key thing on this one is, again, that for the and part, that means it's the overlap. So once we get, now we're still going to have to graph it. It doesn't ask for the graph, but so we can kind of visualize and see we're going to graph it anyway, just to kind of get the setup here. So for this one, we're going to subtract 3 from both sides. So for solving for that one, we have W would be less than -4. Okay, on the right-hand side, subtract 5. Divide by 3, so we got W is greater than or equal to 2. Now, when you graph these two, and again, we don't have to have the graph, but the graph kind of gives us the marker. We're going to start at -4. We're going to open circle going this way. For the green, we got a solid circle at 2, and it's going that way. Again, key thing is the and is the overlap. There is no overlap. So if there is no overlap, then there is no solution. Now, if you had had a solution, they probably would have asked for the answer in interval notation. So if, let's just for a moment pretend that, let's say the answer had been between -4 and 2. If you had graphed that and that had been the answer, then that solution would have been -4, 2, and you would use the parentheses with the -4 because it's open circle. You'd use a square bracket with a 2 because it had the solid circle there. So this was our what if question. What if it actually had some overlap to it, and that had been the answer we were looking for? Because they didn't ask for the graph, they would have asked for the answer in interval notation. Okay, for 13. Another one would ask you to solve, and again, no graph on this one, just a plain solving. And this one is just an equation. There's no less thans or greater thans for this one. And as long as that's an equal to a positive number, this is where you just split off in the two cases, that 6v minus 15 could equal -3. Or 6v minus 15 could equal a positive or just a regular 3. So working with the left-hand side, you get 6v equal to 12, or v equal to 2. Right-hand side, 6v equal to 18, or v equal to 3. And 14, another absolute value similar to it. The difference on 14 is they ask you to graph the answer on a number line. Okay, and the big thing on 14 is when you're doing absolute values with less thans and greater thans, everything depends on what that sign is, because that sign's going to tell you whether this is going to be an and statement or statement. Since this one is less than, then less than was an and statement, which means this thing has to be sandwiched between +3 and -3. Okay, and when you sandwich this one in, because normally we'd put the x minus 6 first, and since it's kind of backwards, we're going to have -3 less than x minus 6, which is less than 3. That technically x minus 6 is greater than -3, but because of the way it's written, we're going to do that. So anytime this is a less than statement, it's sandwiched in between the two. If that had been a greater statement, that's when it would be an or statement, and that's where it's going to look like oars on a boat. That one's going to be less than 3, the other one's going to be greater than -3. Okay, and to solve this one, we're going to add 6 to all 3 parts. And then that would be the answer solving it, but it asks you to graph it on a number line. So for this one, it's open circle at 3, open circle at 9, and then everything in the middle. And 15, pretty much the same type of question, just a little bit different solving that you have to do. So same directions on this one, still graph on a number line. The only difference with this one is you have 5 times absolute W is greater than 30. And again, for this one, before you can do anything, you have to get this absolute value by itself. So divide by 5 on both sides. So absolute value of W is greater than 6. And because that's greater, that really means it's an or statement. So when we split this thing up, we're going to have 2 parts. It's going to be W is greater than 6, or W is going to be less than -6, because when you throw the negative in there, you've got to flip the inequality sign. And let's put the negative first, because that's normally the way we used to see it. So the positive number stays like it is. When you throw the negative in there, you've got to flip that inequality sign. So on the number line, this is where it's going to look like oars on a boat, because we've got it greater than 6. I'm going to have it going less than -6. So if it's an and statement, if it's less than, it's sandwiched in between 2 numbers. And if it's a greater than statement, it's an or statement. Looks like oars on a boat, that it's on the outside part of it, that you've got this gap in the middle. Okay, and here's where we get as many in as we can. That for 16, here's where they ask you to Square root of 25, they ask you to name the value. And again, they kind of give you the hint that they say name the value, not values. So they're looking for one number. Square root of 25 is 5. Pretty straightforward. 17, same thing. Name the value, still just, so they're asking for just one answer here. And if you square root of 64, that's 8. Square root of 9, that's 3. So that answer is just 8 over 3. Okay, 18. Same thing, but this one has an A and a B answer to it, or A and B part to it. And still just name the value, so they're still looking for one answer. If you square root negative 81, this is where they're going to tell you, all right, this one, there is no real solution to this one. So basically that's a no solution answer. Now if you put the negative in front, that part's okay, you get a real number answer. Square root of 1 is just 1. Put the negative in front, so that one is negative 1. Okay, so those three with the square roots, again, they're looking for one answer, and they should tell you to find the real value. They don't do anything with the pluses or minuses there, so it's pretty straightforward. 19, they changed it up just a little bit, and now they say just to simplify. And this one goes to a third root. So if you had the third root of negative 125, this is where you'd have to take the 125 and break it down. And because it's negative, you could do a negative 5 times 25, and with that one you can make both of those negative, because a negative times a negative would be a positive. So that's the third root of negative 5 cubed, because you have 3 negative 5s. Third root and third power cancel each other out. So that should just come out to be negative 5. And again, if you're doing third roots or fifth roots, negatives are okay. Those problems are fine. It's when you have second roots and fourth roots, that's when you have to stay away from negative answers. So as long as that's an odd index or odd root out here, you can have a negative answer for those. All right, let's do number 20, and that may be the last one of the night here. Okay, so for 20, we've got the third root of 125v to the 18. Okay, we just did the third root of negative 125. So if we do the third root of 125 positive, that's going to be a positive 5. And then for the v, that's where you're going to take the power and divide it by the index. So it's 18 divided by 3. So it's v to the 6th. So for that one, that would be 5v to the 6th.